In this video, I'll explain the meaning of derivative in a context. When explaining the meaning of f prime of a equals b in context, using the instantaneous rate can be accurate but often does not convey much meaning. If rate is not constant, then it need not be true that for any one unit change in the independent quantity, the dependent quantity changes by b units. If f is differentiable at a, then there is a sufficiently small amount of change in the independent quantity from a where the graph of f is indistinguishable from a line. So f of a equals b means that as the independent quantity varies by sufficiently small amount from a, the change in amount of the dependent quantity from f of a is essentially b times as much as the change in independent quantity. Let's consider a situation where a student Courtney is going on a road trip. The function ft measures the amount of fuel Courtney's car has consumed, where t is measured in hours since Courtney left her hometown. And we happen to know that f prime of 5 equals 2.5. What does this mean? Pause the video and write your own explanation. A common explanation is the instantaneous rate of change 5 hours after Courtney left is 2.5 gallons per hour. This is a true statement, and it identifies the units that are associated with 5 and the 2.5. However, it does not convey much additional meaning. In particular, it doesn't explain what the instantaneous rate of change actually means in the context of Courtney's trip. So we need to come up with a better explanation. To help us think about these potential candidates, let's make a graph of f. For this graph, the horizontal axis will be the time in hours and the vertical axis will be the amount of fuel consumed in gallons. Here's another common description. The amount of fuel Courtney's car consumed increased by 2.5 gallons each hour over the first 5 hours since leaving her hometown. This will mean that if we made a table of values of t and f of t, Courtney would have used 2.5 gallons after 1 hour, 5 gallons after 2 hours, 7.5 gallons after 3 hours, and so on. If we plotted these values as coordinates on the graph, the fuel consumption would look like this. And the difference between these graphs suggests that this interpretation is incorrect. What's happening here is that this interpretation is as a constant rate of fuel consumption from t equals 0 to t equals 5. But Courtney isn't necessarily using fuel at a constant rate. She could be speeding up, slowing down, going uphill or downhill over those 5 hours. Now, the 5 in f prime of 5 means that we're focusing the value at t equals 5 hours, not over a 5-hour interval. So let's make another attempt. Here's another common description. Starting at 5 hours, the next hour Courtney's car will consume another 2.5 gallons of gas. This is an improvement because it's focusing on the 5-hour mark and it's not claiming that the gas is necessarily being consumed at a constant rate. But if we think about what this means on the graph, it's saying that starting at t equals 5 hours over the next hour, the amount of fuel consumed will go up by 2.5 gallons. And this does not match the graph. because it's describing the average rate of fuel consumption from t equals 5 to t equals 6 hours. And we do not know how Courtney drove over that hour-long interval. Now, if we want to describe an instantaneous rate at t equals 5 hours, since this was better than previous attempt, let's see if we can make it a little more precise. Let's start with an average rate of change over a time interval starting at t equals 5. We can write this as change in f divided by the corresponding change in t. And on the graph, the delta t will be represented by this red arrow, and the delta f will be represented by this blue arrow. And the values of f that corresponded the endpoints of this blue arrow are f of 5 and f of 5 plus delta t. So we can rewrite this average rate of change as the difference between these two values divided by delta t. And now we want to look at the instantaneous rate of change rather than the average rate of change. To get the instantaneous rate of change from the average change, we take the limit of average rate of change as delta t approaches 0. And this is supposed to be equal to 2.5. This limit means we're evaluating the average rate of change over smaller and smaller intervals. So let's shrink the delta t interval. And let's zoom in to see this better. When delta t is small enough, the slope starts to look constant. In particular, essentially the constant slope in this window would be 2.5. So for a sufficiently small delta t, the amount of change in f is 2.5 times as much as the amount of change in t. Now that we have all this, let's make another attempt at explaining the meaning of f prime of 5 equals 2.5. We can see that this constant slope corresponds to a constant rate for fuel consumed per hour. So we can explain what f prime of 5 equals 2.5 means in this following way. As time varies by a very small amount from 5 hours, the change in amount of gas consumed from f of 5 is 2.5 times as much as a change in time.